4 atoms in the molecule. D. Sand is a solid, while carbon dioxide, sugar, and methane are all gases. Number 12. How many atoms of hydrogen are in a molecule of ethanol? CH3, CH2, OH. A, 3, B, 2, C, 5, D, 6, or E, 1. Next, 13. As molecules of a substance are heated, what happens to the molecules? A. The molecules expand. B. The molecules move faster and spread out. C. The molecules break down. Or D. The molecules are destroyed. 14. Which best contrasts physical and chemical changes? A. Chemical changes are easily reversible and physical changes are not. B. Chemical changes are changes in state and physical changes are changes in composition. C. Chemical changes create a new substance and physical changes do not. Or D. Physical changes create a new substance and chemical changes do not. For 15 and 16, you need to look at this series of 4 pictures. Take a minute and look at the pictures. What do you notice? Okay. 15. Which of the pictures above are impossible because it shows atoms being created or destroyed? Each of the pictures is something before and after. The left hand is what's there before. The right hand is what's there after. Okay, so for 15, which of the pictures above are impossible because it shows atoms being created or destroyed? 16. Using the pictures above, which picture represents molecules being boiled? Using the pictures above, which picture represents molecules being boiled? 17. Using the pictures above, which picture represents molecules being chemically changed? Using the pictures above, which picture represents molecules being chemically changed? Next, 18. What happens to an ice cube as it melts? Choose all that apply. That means you can have more than one answer for this question. What happens to an ice cube as it melts? A. The temperature increases. B. The solid ice cube becomes a liquid. C. The temperature remains constant at 0 degrees Celsius until all the ice melts. Or D. The temperature decreases. Which of those happen to an ice cube as it melts? 19. The equation to calculate speed is the change in distance. 19. The equation to calculate speed is A, the change in distance divided by time. B, mass times acceleration. C, the change in time divided by distance. Or D, change in speed or direction over time. Which of those is the equation used to calculate speed? 20. What changes the speed or direction of an object? Okay. What changes the speed or direction of an object? A. Inertia. B, velocity, C, acceleration, D, a force? What changes the speed or direction of an object? 21. If a moving object is slowing down, a force must be A, pushing or pulling more in the same direction, B, running out, C, pushing or pulling more in the opposite direction, or D, being used up. If a moving object is slowing down, what must happen to the force? If force must be, which of those? 22. Which of the following is an example of acceleration? A. Jesus' speed is decreasing as he jogs up an incline. B. Julie is walking at a constant speed and turns the corner to go to her house. C. Justin pedals his bike faster to get to school on time. Or D. All of the above. 23. What happens to the speed when the total force on an object is 0? A. The speed is constant. B. The speed increases. C. The speed decreases. Or D. The speed increases, then decreases. What happens to the speed when the total force on an object is 0? 24 and 25. 24 and 25 are both related to the story about the student. Make sure you read all parts of an exam. Don't skip over the readings. A student stretches a slinky between two chairs and attaches it to the chair. The student moves the slinky to make a wave. Assume no energy leaves the system. 24. What is the relationship between the final amount of energy and the initial amount of energy? A. The final and initial amount of energy are the same. B. The final amount of energy is greater than the initial amount of energy. C. The final amount of energy is less than the initial amount of energy. Or D. The amount of energy cannot be determined. 25 is also related to 24. What principle is this? A. Miss Ellis. B. The law of conservation of energy. C. The law of energy talking. Or D. None of the above. For 26, 27, and 28, you need the picture that's above the questions. As a pendulum swings, its energy is constantly changing from potential to kinetic energy and back again. 26. Where is the maximum potential energy and minimum kinetic energy? A. At the top. B. In the middle, at exactly halfway. Or C. At the bottom. 26 is asking, where is the maximum potential energy and minimum kinetic energy? 27. Where is the maximum kinetic energy and minimum potential energy? A. At the top. B. In the middle, at exactly halfway. Or C. At the bottom. 27 is asking, where is the maximum kinetic energy and minimum potential energy? 28. Where are there equal amounts of both kinetic and potential energy? A. At the top. B. In the middle, at exactly halfway. Or C. At the bottom. 28 is asking, where are there equal amounts of both kinetic and potential energy? At this point, you are done with the quiz. You need to write down what time it is. That way we can make sure you're in the right room when it comes to TCAP. That way you don't have to wait too long and you don't run out of time. Thanks guys, good job.